Hello viewers, welcome back to the Multimagics channel. Myself is Funny. Hope everyone had a great Christmas time. I wish all our viewers and subscribers in advance Happy New Year. And on that note, we will start today's video. So this particular video is about how to build FFmpeg sources. I mean the FFmpeg libraries and binaries from sources for the Raspberry Pi platform. So in the next slides, we will see what is Raspberry Pi, what is this embedded domain perspective, what is this Raspberry Pi, how it is useful, why we are going to this particular platform, and how to build image and how to flash. All those details we'll go through. So let's start on that note. So yeah, so far the as you everybody know, the Multimagics platform we are supporting for multiple platforms. So we are there on iOS, we are there on Mac, we are there on Android, we are there on Linux, we are on Windows. So on Raspberry Pi we are not there yet. So as a part of taking our baby steps into this particular product, so first we want to ensure we build FFmpeg from sources for this particular platform. So why we are going to this Raspberry Pi platform is because, see, let's assume we have a server and that server is running up on Raspberry Pi, and any web agent or any web client or any web application can connect to that server and then do all the media conversions all there, and then you can finally get back the converted video to your web engine or to the web application. So keeping that in the long from that perspective point of view, the first phase or the first thing to ensure is to build the FFmpeg on this particular platform, on this particular RPi platform. Okay. So the next thing is, so what is this Raspberry Pi? See, Raspberry Pi is one of the target board. So in the embedded domain, we will have host board and the target board. Target board means the way your image is running. And then in this case, the target board is Raspberry Pi, and this Raspberry Pi, we have different versions, and the version we used for our purpose is Raspberry Pi 3, which is a model B and which is a revision 1.3. And like any other like general purpose operating system, this particular Raspberry is all has a processor, and the model is its ARM, and the model is Cortex A53, and RAM is 8 GB, and the architecture is 64 ARC64, and ports is HDMI, USB, and LAN. All the ports are available just like any other general purpose computer, and it has a built-in Wi-Fi module, and it has a 32 GB micro SD card, and it also supports 32-bit. So this is a kind of hard disk for this particular Raspberry Pi. And then yeah, so this is the how the Raspberry Pi looks. And also we will be flashing Ubuntu desktop image, which is compatible for the ARM 64 and Raspberry Pi. So this particular image I have downloaded the link mentioned here. So I downloaded it, we have flashed it, and then we have gone through the next steps. Okay, we'll go through that one by one. So first thing is we need to know what is the development process. See, very simple. So this is the target board. So we want to run all our applications on this particular board. Since this we cannot directly set this particular thing as a development environment. So the alternative way is like we need to build everything from our host, like our regular desktop machines, which we are quite comfortable, and like a lot of other additional advantages will be having. This is like more power consumption, and then a lot of limitations are there. So this is like a target board, means we just run applications on it. We don't develop, build all those things on the target machines. It's not recommended, actually, not the best practice. So on the host machine or the build machine, we have all the source code libraries. We do have the cross compiler, and then we generate the executable, and that executable we copy it to the target platform using SSH. So this is how typically in embedded domain you develop to the target board. Okay, so the cross compiler we are using here is GCC ARC6 for Linux GNU, and the host machine we are using is Ubuntu machine, which has Ubuntu operating systems, and the architecture is x86-64. And the target platform also has a Ubuntu, but the architecture is ARC64 to support this particular board. And then yes, and the operating, I mean the processor is of ARM processor. Here it is like x86-64. It is the Intel processor here for host. Okay, So this is about the host and the target and the need for the Raspberry Pi and why we are going for the Raspberry Pi. Okay. So first let's imagine you just have the host machine, you don't have any target board doesn't have any image. So first thing is you need to flash the image. For that you need to install the RPi imager on the host machine. Since my host machine is Ubuntu, I have simply followed these commands sudo apt update, sudo apt install snapd and RPi imager. So after installing RPi imager, you will be getting a UI like this. In this you need to select which model you want to flash. In our case it is RPi 3, and this is the image I have downloaded from the link whichever I have shown, and this is the hard disk or the micro SD information. And then now you click next, so it will flashing process will be completed. So it will take around 20 to 25 minutes. So there will be flashing, there will be verification. So after flashing is done, you can just remove the SD card from your host machine and then insert into the target machine. And of course the target machine is here is the Raspberry Pi 3. So to RPi 3 you can connect the HDMI cable to your monitor, you can connect it to mouse, and you can connect keyboard, so you power on just like using any desktop application. You just log in with your credentials, whatever you have set up during the Ubuntu setup, and then the first thing you have to do is you have to enable SSH. Because we are doing remote development, we need to ensure from the host we should be able to connect to the target machine or the RPi machine. In order to that to happen, we need to enable SSH. So these are the steps to install the SSH, and then this is the command you need to see to check whether a SSH server is running or not on this particular port 22. And also this is an optional step, but it's better to have it. Sometimes even though the server is installed, you need to allow the firewall to allow the remote connection, so it's better to do this also. And also finally, after installing the SSH on the target machine or on the RPi 3, we need to ensure the connection from the host machine is successful. So I have gone through all the flashing and then logged in as a normal any Ubuntu machine and then installed all the required things, the OpenSSH. So now let's see. See, this is my host machine. Okay, so my host machine is of type Linux and it has architecture x86-64. So now I will connect to my target Raspberry Pi. So this is the command I use. So SSH, and that is the username of my target machine, which is RPi 3, and this is the IP address. Yeah, so this IP address you need to get from the whenever you logged in first time after installing OpenSSH using ifconfig a or ipconfig -a, you can get all the IP address. So now this is the IP address. Okay, so now let me give the password. Okay, it's connecting. Yep. So now see, you can see here. So this is the username. Sorry, my bad. So the right command is vmi. So this is the server name, and let's see the operating system type. It's Linux type, and let's see the architecture. It's ARC64. So this is about the target machine, and we can also give this command lscpu. So this gives some more additional details about your machine, like what is architecture, what is the model, and then what is the CPU processing speed, and then cache memory, and all other details you'll be getting here. Okay, so now this is about the target machine. So now from the source we have flashed the Ubuntu image onto the Raspberry Pi 3. So after that we explicitly connected to the Raspberry Pi 3. We have installed OpenSSH, and then we have also gathered the IP address of the particular target machine. And at this point you can disconnect from the, or you can just remove the display, all other things, or leave that target machine running silently aside, and now connect to your host machine. And from the host machine connect to the target machine using the SSH command which I have just shown. So I think so far everyone are able to understood until this point, until the connection status. Okay, so the next thing is, okay, so I have the target machine and I want to run some binaries. So, but before compiling the FFmpeg or before generating any libraries, I want to just check whether the platform is up and running good, or the platform whatever cross compilers we installed, hello simple hello world example is working properly or not. So these are the compilers for the ARM64. It supports the ARM64, so you need to install these three things: GCC ARM64, binary utils at G++, and you can also install this if you want to generate in 32-bit, because our current R/3 supports both 32-bit and 64-bit. Okay, see here you can see the file hello world, and you can see the architecture. Let's go into that part first. Okay, so now let's see. Let's exit from the target board, and this is my currently I'm in my. So this is the I have a hello world program. So this is very simple. So let's do one thing. Let's first build it the executable for the target for the host machine. So which is hello world.cpp hello world underscore, let's say this is the host machine. Okay, so let's do the same thing for the yeah, so you can do this. So this is the cross compiler G++, and you can also do hello world.cpp hyphen o hello world underscore target. Okay, again, or you can, since our target is at 1.3, I will mention like that. Okay, so now let's run the both the executables here from the host machine. So it's hello world.host. So host is good because you are running from the host machine, and the compiler also you are using the host machine. So now let's see what happens to this R/3. Yep. So there you go. See, because this is the executable which is meant to run on the ARC64 processor and the ARM processor. So if you go and see file hello world underscore R/3, and if you also do this file hello world underscore host, you can see the difference here. So this is our we built it with the cross compilers for the target board, which is R/3, and the architecture is ARM. I mean, after ARC64 and the processor is ARM. So if you are trying to run this particular binary on the host machine, which has a different architecture and which is a different processor, it doesn't the instructions are not understood by the processor, and then it is tough. It is not in an unrecognized format. That's where getting this particular error here. And this is the host machine. This is same. It is as it is function. It is executable architecture, and then yeah, it is executable here. So now how to execute this particular binary? So now you need to transfer these particular command. So you can use this scp command and transfer your files to the host machine. I have already did it. So let me connect to the target board, which is R/3. Okay, there you go. It's connecting. Okay. So here if I go to, so this is my target machine, which is R/3. So here I already have this hello world architecture 64. So if you go here and just quickly cross check whether it is for this particular platform, yes, this is meant for this particular platform. And then now I can type hyphen hello world. Yep, so there you go. So if on this particular target machine, we are able to run this particular executable hello world. And if you try to run the same executable on the host machine with a different architecture, it gives error. So that's how the development process goes. Everything you build on the host machine using cross compilers, and then you copy that particular executable or the necessary files to the target machine, and then you start executing things there. So that's how in the embedded world the development process goes and the deployment process goes. And now the major big thing is how to run the FFmpeg. So this is all the information whatever I have just shown. So now the interesting part is how to build FFmpeg from sources for Raspberry Pi. So what are the steps we need to do? So first, on the host machine, you need to download FFmpeg version 6.1, and you just untar it. And after untarring it, you create a separate directory called build, and then you enter into this particular FFmpeg folder. So now you need to configure your uh, particular RPi. I mean, you need to configure the FFmpeg on what are the things that needs to be embedded in that particular libraries. So by default, all the libbaby codec, libbaby, all those binaries or libraries will come. So for now, I am just excluding the dependencies. At first layer, we want to check at least the basic default FFmpeg features are building. Okay, so I'm not enabling any external libraries. I am just using the basic features that are supported by the FFmpeg. So this is the syntax you need to follow. You need to enable cross compiler, and you need to tell this cross prefix is equal to arc64 linux gnu hyphen, and this is the based upon the uh, code. It will use either GCC or G++. We just need to leave this like declare like this here, and the architecture need to mention, which is arc64, and the target was you need to mention, and the prefix is what you need to mention, where to store all the binaries as a part of make install. So after configuration, you will be showing make -j4, and you need to do make install, and at this point all the binaries are generated, uh, or and the libraries are also generated which supports this particular target machine, which is Linux, which is ARPi3 and architecture 64 ARM processor. Okay, so now let's see. Okay, let me quickly go through what I have done. So if we go to this particular folder, and then I have already downloaded the FFmpeg source code here, which is version 6.1, and then I already built it here. If you go to the build folder outside, I mean, yeah, I think it is here. Okay, 6.1 build. Yeah, so in this build folder, I already had the FFmpeg, fprop, and then the include of libav codec, AV format, AV. Also, FFmpeg build is successful. I just followed the commands whatever I mentioned in the earlier slide. Just configure it properly with the cross compilers, and then do make -j4 and make install. Everything will be shared here. So now these things you cannot use it straight away in the host. So you need to copy it to the target machine. So after going to the target machine, you can use them. So if you do this, now let's log into the target machine again here. So, okay, so SSH, okay, R53. Oh no, okay, my bad. Once again. So okay, let's log in SSH. It is magics R by 3 hyphen server 1 at the rate 192.168.0.1. My bad, 168.0.106. Yeah. Okay. So why it is okay? I think I am my bad. So we are already inside the target machine. Okay, we are already inside the R by 3 server 1, and then we are already inside this particular folder called media soup, where I have already copied that particular build folder. So let's go into here, and then first let's go to the binaries, and then let's check the file format. So FFmpeg. So as you can see here, it is like ARC64 ARM processor, and then if you do this, you can cross check like this to FFmpeg hyphen build conf. It says okay, so this is my configuration I have used to build this particular FFmpeg version from sources, and these are all the versions of the libraries which were installed as a part that came as a part of this build. This is about the binaries. So this is if you go to the lib, yep, these are all the libraries that are generated. So as I mentioned, these are all the basic things which I have covered. I mean the basic FFmpeg without any other external dependencies. For in general, for our multimagics, we use a lot of external libraries like libmp3, x264, x265. So that we will cover in the next part, how to build FFmpeg for Raspberry Pi platform with external libraries. So the first thing is we achieve this thing, how to build. So this is all we have already shown. And there is also one more command, FFmpeg-encoders, where you can see the list of all the encoders. Okay, so that you can go through once you install on it. So as I mentioned, the next plan is to build FFmpeg with external libraries like MP3, X264, and X265, and also build the Multimagics console application based on above libs using cross compilers. So until this part, we are only building FFmpeg, and later that with the help of those generated libraries, we will build our Multimagics console application. So far we have seen how to build FFmpeg on Raspberry Pi, and also what are the basic steps you need to go through, and how to enable SSH, and how to flash it, and how the basic development environment looks like, and also what is RPi, and how the, what are the things we need to take care in embedded domain. So before, if you're working on a particular architecture target board, you need to at least get these basic details. So it gives like a lot of other details you need to gather, and then just you need to just follow cross compilers option, and then just like running on basic host, you need to just change the compilers. You need to use the cross compilers which are supporting for that particular architecture. So I hope I'm clear with today's concept. If you have any questions and queries, you can definitely reach us through our blog, or you can just put in the comment section your feedback. So that will be really appreciated. So for now, everyone have a good evening and take care. See you with a new video in the next week. Thank you.